Hello again everybody, Jesse here. Well done on completing lesson 5.2, which was all about the Carrington event, one of the largest geomagnetic storms in recorded history. This was observed directly by Richard Carrington in 1859. He was monitoring a pair of large sunspots, and he noticed a solar flare emerge from one of these sunspots. The solar flare was accompanied by a coronal mass ejection, which arrived 17.6 hours after he observed the flare. Normally, a CME takes between 24 hours to 3 days to cross the distance from the Sun to Earth. The faster it's moving, the shorter the time period it takes, and the more energy it carries. Now, I should stress here that in the days leading up to the Carrington event, there was lots of aurora viewed from locations closer to the equator than usual. And it's thought now that the CME leading up to the Carrington event cleared the interplanetary magnetic field of ambient solar wind, and this allowed the Carrington event coronal mass ejection to arrive packing the biggest punch possible. Because of that, it triggered a very powerful geomagnetic storm. It was observed across the world, including equatorial areas like Colombia, I believe it was viewed in. And in the United States, it shone brighter than a full moon. And this NASA animation is a model of the 1859 Carrington event coronal mass ejection. The first one here is based on a big one from 2006. This represents big Aurora, but the one that arrived in 1859 all but swept away Earth's magnetosphere. Look at that dark red colour, that high density of solar wind, and look at the way it's distorting and morphing Earth's magnetic field. Absolutely incredible. We're still protected by what's left of our magnetosphere. We're still not in any physical danger here, but our technology is. Now, the primitive technology in 1859 wasn't really affected because there wasn't much technology to affect, but what did exist was affected quite severely. The emerging telegraph system was pretty severely affected. The Carrington event accelerated electrons through the ground-based equipment. There were electrocutions of telegraph operators, compasses failed, there were power surges and fires, and because of the overly saturated grid, telegraph operators unplugged their equipment. But despite that, Earth's magnetic field was going so haywire, there was still a current flowing through that unplugged equipment, and they could still send messages in Morse code. Just take a minute to consider the implications of such an event in this day and age, based on the fact that we've got so much more of a technological infrastructure. We have GPS satellites, we have credit cards, debit cards that rely on satellite communications. We have a much more extensive grid, we have electric cars, we have laptops, and so on and so forth. We rely on electricity enormously. And this event, this Carrington event, it wasn't an anomaly. There will be another one. In fact, a recent study calculated that there's a 0.7% chance of a Carrington event style CME being Earth-directed every single year. And in fact, we had a near miss in 2012. In 2012, there was an Earth-directed Carrington event style CME. It was headed right for Earth, but it missed by a distance of 750,000 miles, which does sound like a lot. But that's only 3 times the distance to the moon. Astronomically speaking, that is a very, very close shave. And in the next and final lesson, we're going to look at how humanity, how our global society can prepare for space weather events such as this to minimize the disruption that it causes. So we'll have a look at that in the next lesson, and I'll see you later on.